Okay. Okay, so what I've done is I've put the equation of two lines up on the board. So this is like line 1, we'll call it L1, and this is L2. And the question is whether or not these are parallel, perpendicular, or neither. So if you have two lines sitting out here, they can be parallel, they can be perpendicular, or they can be neither. So there's really three possibilities. So here are the two lines, and you're asked which of these three cases is it. So how would you do that? Yeah, just find their slopes, right? If you find their slopes and compare them, then you'll know. If the slopes are exactly the same, then they're parallel. If they're opposite reciprocals, then they're perpendicular. And if they're not one of those, then it's neither, right? So let's find the slope of this first line. To do that, we would have to solve for y. Agreed? So I'd have to move that x to the other side. Moving the x to the other side means it becomes a negative x. And then we still have negative 3/5 y. Now, how do we get rid of the negative 3/5 on the left side? You could divide by it or multiply by the reciprocal, however you want to do that. Let's see, that's going to be a little weird. If I divide this by negative 3/5 y, I'm going to have y. Over here, I'm really taking negative 1 and dividing it by negative 3/5. And I still have x there. And then plus 1 divided by negative 3/5. So just make sure you understand that there's a 1 sitting in front of that x. And you need to divide that, well, negative 1 sitting in front of that x. And you need to divide that negative 1 by negative 3/5. What is negative 1 divided by negative 1 divided by negative 3/5? It's positive 5/3. So be careful with that. You're doing negative 1 divided by negative 3/5. Right, that's what we're doing. That's really like negative 1 over negative 3 over 5. And this will flip up, and the negative and negative become positive. Do you all see that? So that becomes 5/3. So y is 5/3 x. Then what about this? What does that become? Minus 5/3. And what's really the only thing I care about here? The slope, right? So what is the slope of this first line? 5/3. Okay, now we have to do the same thing for the second line. We have to find its slope. So for the second line, solve for y again. So 5y equals what? Negative 3x. And then those 4's are going to cancel, right? When you subtract 4 on both sides, they go away. So all you have is that. Divide by 5. And you get what? Negative 3 over 5x. So there's your slope. So are they parallel? Well, they're not the same, right? So they're not parallel. Are they perpendicular? Yes. They are opposite reciprocals. Or sorry, yeah, opposite reciprocals. Okay? So perpendicular. Any questions on that? Okay. Let's talk about the review a little bit. Were there any questions on the review yet? We still have more material to cover, okay, but while we're still talking about lines, was there anything on the review that you wanted me to address? See if I can't get in here. Whoa, what happened? There we go. I'm just going to kind of put the review up here and see if there's anything on here that stands out. Come on, you can do it. All right, so it says up there, Exam 1 review spring 2017. So this is an old review. So the first two problems are just arithmetic. Y'all okay with that? Batch of cupcakes, we did a problem like that in class. Perform the indicated operation, we did something like that in class, right? So far, everything looks familiar. I gave you a quiz on something like number 5 and 6. Actually, isn't that exactly 5 and 6? Yeah, those are the ones that I still need to give those back to you. Number 7 is a solve problem. Oh, okay, this one, 8, we did one like that, didn't we? GCF, factoring out, common factor, we did that. Number 10, 200 is what percent? So I guess what I'm getting at is nothing here looks crazy, right? This all looks within what we have done. Number 13. 13. Wasn't this like the one? Okay, so only one student asked me about this problem, and this one is a little bit tricky. Oh, the fish one, the tagged one, we did one like that in class. That was an estimation problem. So I think everything up to number 12, you could go back into lecture. You could even watch a video of me doing a problem like those, right? Okay. Number 13, I have never talked about. But there was one in the homework like this. If there are 78 male students for every 90 female students at Northwest Vista, then what percent of students are male? And so people were having some trouble with this. But let's just look at it this way. If you have male and female students mixed up here, right? Both male and female. 78 will be male. For every 90, that'll be female, right? So it says what percentage is that? Well, what percent are male? So the percent will be the 78 males divided by what? Not 90. because that would be a ratio, that would be a proportion of males to females. We want the males to the total number of students. So what you have to do is take 78 and divide it by these two numbers added together, which is 168 when you add them. Right? Does that make sense? And then whatever that number is, as a decimal, you convert it to a percentage. Do we need to update this? Shut up, Robert. Do we need to update this? Shut up. Yeah. Okay. Well, the military has more than one selection now, right? Male, female, there's other. Yeah. The military does. Yeah. Yes. Yes. No? They do now. I thought that there was more than 2 options in the military now when you enroll, when you enlist. No? Still male, female? I don't know about that.
The draft I thought was just male.
They don't care about your feelings.
I thought they just changed it like the other day. I don't know. I heard something about
I've heard that there's more than 2 options.
Yeah, that's what I've heard.
Yeah.
Like recently. Like
Yeah.
very recently.
Yeah. Okay, yeah, like I said, we're not going to get into that. All right, so a new computer is normally $2,000, but it's 15% off today. If you buy the computer today, look, we did one just like this, right? $2,000 a day, 15% off. So first thing you do is find the sales price. So how would you find the sales price? 2,000 times? Remember, there were 2 ways to do this. You could take 15% and then subtract it, or you could just multiply 2,000 by 0.85, right? If you're taking off 15%, it's the same as paying 85%. So, and then after you do that, then you take the sales tax on that. So we did one like that. What about this real estate problem? Real estate tax for a $165,000 home is $2,800. At this rate, what is the real estate tax on a $540,000 home? Didn't do anything like that in class. This is proportion. So what are we looking for in this problem? What are we trying to solve for? The real estate tax, right? The real estate tax. And the first sentence gives me a proportion. It says, you know, $165,000 home, right? Over the tax on that home is $2,800 tax, right? That's a proportion that's set up in the first sentence. I can use that proportion that way or the other way, flip it over. If I'm asked for the taxes, right, and given the price of a home, then my tax, I'll call it T, over the home price must be proportional to that over there, but make sure you get the tax on top. So 2,800 over 165. And then you just solve for T. So figure out what this is, multiply both sides by 540,000, you get the result. So I guess the main thing here is just make sure that you get tax on top, home price on the bottom. All right, can I move on? Okay, let's look at 16. Find the slope of a line which is perpendicular to the line through these 2 points. Find the slope of a line which is perpendicular, which means it's going to be the opposite reciprocal, of the line through these 2 points. So what do you have to do? Find the slope of this line, right? There's 2 lines in this problem. One that you're looking for the slope of, and the other one they're giving you the 2 points. So you find the slope between these 2 points, y2 minus y1 over x2 minus x1. Take that answer, flip it, change the sign. That's it. Yes?
Are there going to be any conversion questions?
Let's keep going. Let's keep going. Write the equation of a line which is perpendicular to this line with the y-intercept of this. Now this is a little bit different than what we just did. But it's the same, but it's kind of hidden. The problem that we did right before we ended before we took our break, didn't I give you a point and then a line? I said find the equation of the line through this point perpendicular to this line. That's what this is saying, except the point that you're given is kind of hidden. It's a y-intercept. Isn't the y-intercept a point?
Yeah.
What is it? What is this point right here? 0, -4. So see, you have a point given to you. And then what you need to do is take this line, figure out what its slope is, flip it, change the sign, and then plug into that formula y minus y1 equals m times x minus x1. Make sense? Sure? Are these parallel, perpendicular, or neither? We just did one of those. All right, so this is a problem. Look at this one right here. Write in slope-intercept form. Find the x-intercept, find the y-intercept, and graph the line. I'm telling you to do all of those things. So the first part, write in slope-intercept form. What am I telling you to do there? Yeah, you want to solve for y. You want to get y by itself, right? Okay, what am I asking you to do here and here? You can actually go back to this right here. To find the x-intercept, you can let y be 0, solve for x. To do this one, you set x to 0, solve for y. Right? So I'm having you do both methods in one problem. At least that's what I had them do during their test, right? And then after that, you get to graph it. But if you have the x and y intercept, 2 points, graph, it's going to be pretty straightforward to graph. Does that make sense? Same exact question. Number 21 and number 20 and 21 are the exact same instructions, 2 different equations. So you can see this one has, a little bit more to do, messy numbers, I guess. This one's got some fractions in it. All right, let's take a look at this one. I plan to exercise and diet to prepare for a triathlon. If my starting weight is 178 pounds and I can lose 0.25 pounds per day, then answer the following. I know there's some people that work out in here. Does that seem realistic to lose 0.24 pounds a day? Quarter pound a day? Seem like that's achievable? Okay. The first thing is to write a linear equation which gives my weight in terms of the number of days I have been training. Part B, how much will I weigh in 1 week? And lastly, how long will it take for me to reach my goal of 160 pounds? I don't think we did anything like this, which is why we're going over it. Make sure we can do something like this. All right, so what's happening here? You've got your weight starting out at 178 pounds, right? I'm just going to kind of draw a picture. Let's say this is the number of days, and this is your weight. And you're starting out at day 0 at 178 pounds, right? And then losing 0.24 pounds a day means that you should start to trend down like this, right? And that means that we should have some sort of linear equation representing what's going on here. So you remember when I started lines in the very beginning, I talked about, I think it was Sam worked at a car dealership and he made a certain amount of money just for showing up and then a certain amount for each car he sold. It's basically the same type of thing. We have a starting weight, okay, which is like Sam's salary for just showing up. But then you're going to be subtracting from that right? The starting weight of 178 pounds, you're going to be subtracting 0.24 pounds every day. So how could I write this as an equation? Let me see. Let me use some letters that make sense right now. The weight, right? I'm talking about myself here. So my weight, W, is going to be 178 pounds minus 0.24 times D. Let's see if that makes sense. The weight, my weight, should be 178 pounds, which is my starting weight. Take away 0.24 pounds for each day that I work out. So at day 0, right, this is 0. At day 0, I'm 178. After 1 day, I'm going to take away 0.24 pounds. After 2 days, double that, right? 3 days, triple that. So do you all see this? Yes? All right, so let's see if we can't answer. This is the main thing. You're basically setting up a linear equation in 2 variables, just like that. So that's part A. Now, if on a test you use y and x, that's okay. All right. How much will I weigh in 1 week? So what is part B asking you to do? Find the weight, right? Find the weight. So use this equation. Weight will be equal to 178 minus 0.24 what? Times 7. Because this is the number of days. So 1 week later is 7 days. And so somebody on their calculator? What is it?
The total weight's 170, oh, whoa, 176.
Whoa.
You got 2 different things.
I'm sorry.
0.24.
I was solving the whole thing.
1.68.
168?
1.68.
Oh,
is,
1.68. So you weigh 173 point what? No.
176.32.
176.32 pounds after a week. That makes sense? Okay. How long will it take to reach my goal? How long means the number of days, right? To reach my goal of 160 pounds. 160 pounds, that's a weight, isn't it? So we're going to use the same equation. We're going to replace W with 160 equals 178 minus 0.24 times D. This time I don't know what D is. I'm trying to figure out how many days it's going to take to reach a weight of 160. Anyone have it yet?
75 days.
75 days? So how did you do that? First you move 178 to the other side, so you subtract it, right? So 160 minus 178 is negative 18, right? Equals negative 0.24D. And now divide both sides by negative 0.24. And what did you say again that was? 75 days. So it's going to take 75 days to lose 18 pounds. Anyone here ever do a triathlon? I used to do triathlons back in my early days. But it's probably a pretty disgusting idea, but I used to actually compete at like 158 pounds. That's what I compete at. It's like sickening skinny. Yeah. When I first met my wife, I was doing a lot of triathlons. And she told me I was sick. She thought I was sick. She thought I was like dying or something. No, not dying. Okay. How was that? Do you think you could handle that? Okay. All right. Ooh. Let's scratch 23. Let's just not even worry about it right now. We'll do that on the next test. Okay? Now, I know some people are asking about the proportion, or not the proportions, the conversions, right? So I think what I'm going to do for conversions is I will give you some problems on conversions, but I think I'm going to do that more of like a out-of-class take-home thing, because like I told you, like at the end of the day, it's kind of outdated a little bit. It's even worse than, like, you know, calculators help us do arithmetic, but really when it comes to conversions, I mean, that's what professionals will do. They'll go to technology because they can't afford to make a mistake, right? You don't accidentally give someone the wrong dosage of medication, right? So you have to be extremely careful with things like that. So I think realistically, real world, you have those resources for you. And so does that seem like a pretty thorough exam so far? I mean, it covers pretty much what we've covered. I don't see anything other than the conversions. Nothing else is really missing. All right, so we're supposed to talk about functions, and that's the last thing that's on the exam, but it's not on the review. So we do have an additional topic that'll be on here. So I'll talk about it today, and then when we come back on Monday, I'll show you what types of problems to expect on the exam in relation to this stuff. All right? And I apologize if it seems like a lot of material, but it is summer, 8 weeks, right? So we are condensing quite a bit of information, and you signed up for it. All right, functions. Come on, let's go. So let me put the definition of a function up here for you. A function is a rule which assigns to each input exactly one output. Now that's a very nice way of saying what a function is. There's other definitions that are a little bit more mathy, okay, in terms of the language. But here's basically what's happening. We start out, and you may have seen this before, a lot of people like to look at functions as machines. So what you start out with is a number. Okay, you start out with this number, and you send it through this machine. Okay, so this machine right here, put a little smokestack on it. It's doing some work. It does something to the number, right? We usually like to notate this function with an f, a lowercase f standing for function. It takes that number in. So this is the input, and then it takes that number and it spits out a number. And this is the output. A function is a rule. So the rule is like what the machine is doing, all right? It's a rule that tells it what to do, what it's going to do to this number. Maybe it's going to double it, maybe it's going to cut it in half, maybe it's going to square it, who knows. It's going to do something to it. And then for each input that goes in, there's exactly one output. And the key word here is exactly. One output. Exactly one output. A function has to behave that way. One number in, one number out. You cannot have one number in, two numbers out. If it does that, it's no longer a function. And there are examples of things that take one thing in and spit two things out. There are examples of those, but they are not functions. We are focusing just on functions. So let me give you some examples of functions. This is going to look familiar. Okay, if I asked you, what is this? If I asked you to graph it, what is it? It's a line, right? Isn't that a line? Okay, a line is an example of a function. So if we were to look at it like a machine, if I were to start with x, send it through this little machine, which we're calling f, and it comes out with some number y, then it acts as a function. So somebody give me an x value. 4. Okay, so you take 4, it goes through this machine, right? Through the function, and what does it come out as? So if you plug 4 in here for x, what is going to spit out of this machine? 13, right? 4 went in, 13 came out. And you could do that for any number. Plug in 0, send it through this machine, and what comes out? 1, right? So this is an example of a function. The input here is x. The output here is y. Do you all see that? Okay, so when we have something like this happen, we have a special notation for it. What we do is we scrap the y, and we replace it with what we call functional notation. And we put f with a little parentheses and x inside of it, and then we just rewrite everything 3x plus 1. And all this tells you is that the output, okay, the left side of this equation, the output is a function of x. X goes in, and then once x goes in, once you plug something in, the output is whatever the number is. All right. So it's a stronger condition than just being a linear equation. It has this property that one input goes to exactly one output. Now let me show you an example of something that would not be a function, so you can see the difference. All right. So what about this? This might take some thinking here. Look at that right there. Y squared equals x plus 1. Is this a function of x? So let me see here. I'm going to pick an x. I'm going to send it through, and it's going to come out as a y. All right, you ready? I'm going to pick the x myself. How about 8? What would come out if I plug in 8? Okay, so 8 goes in, right? You get 8 plus 1 is 9, right? Y squared must be 9, which means that y had to be what? I heard it. 3? Do y'all agree with that? But is that the only thing it had to be, or that it could be? It could have been -3. Couldn't have been? Think about that again. 8 goes in, you get 9 over here. So you get y squared is 9. What number squared gives you 9? Well, I agree, 3, but then also -3 squared gives you 9. So that means that 8 actually could have turned out, when you plug in 8 for x, it's going to spit out either 3 or -3. So do you see how you have one input and two outputs? This is not a function. This is not a function of x. And therefore, we would never use functional notation for something like this. So when you see this notation, it tells you, hey, look, you've got this very strong property that one input goes to exactly one output. All right. All we need to do, be able to do in here, is to be able to work with that notation, evaluate functions, and Later on we'll do more with it, but let's just practice doing some evaluations of functions. All right, here's an example. Let f of x, this function, be equal to negative x squared minus 3x plus 1. So I have just defined a function for you. I'm telling you that if you plug in an x, there's going to be exactly one y that comes out. You're not going to get two answers out. And now I'm going to ask you to do the following. Find part A, f of 2. So let's start with that. So all this means is what? I know a lot of you have seen this. So what am I asking you to do here? What is f? Just plug in 2 for x. That's all you have to do, right? So I'm going to have negative, and then 2 is going to go right here. So 2 squared minus 3 times 2 plus 1. Now, I intentionally did something on that first piece to see if you were comfortable. Like, is this safe for me to put that like that, or should I do something more? Should I use parentheses? What's being squared here? Just the 2, right? Just the 2? So I'm actually going to put that in parentheses. And that kind of forces me to not accidentally pick up that negative sign. I'm just squaring the 2. Because in this notation, I'm just squaring the x. All right, let's work through that. So you're going to square the 2 first, which would give you 4, right? And then the minus stays in front. And then what about this? Minus 6. And then finally plus 1. So we should get negative 9. All right, what is, for part B, what is f of negative 2? So you've got to be careful again with those signs. We've got minus, and then in parentheses, bless you, negative 2 squared, and then minus 3 times negative 2 plus 1. See, it's really important for you to see this, because if you can mess this up. You might think that minus minus becomes plus, right? Because you've always been told that minus minus is plus. But the exponent goes first, because minus minus, that right there is actually multiplication. And so you actually have to do the exponent first. So you have to do negative 2 times negative 2, which is positive 4, but you still have the minus out here. Okay? Then here, what is this? Plus 6, and then plus 1. So what's that? 3? Ooh, f of a fraction without a calculator. Let's see what we can get. So we're doing minus, right? And then in parentheses, we're taking 2/3 and we are squaring it. And then minus 3, and then times 2/3, and then plus 1. So that's just me replacing all the x's with 2/3. So what is 2/3 squared? 4/9, and then minus. So that's negative 4/9. And what does this become? Minus 2? and then plus 1. Put these two together. Minus 2 plus 1 is minus 1. And then how do you put those together? You can do that thing that I showed you in the very beginning. You could rewrite that as 1 over 1 and then do that little doom, doom thing. Remember that? Now this minus sign out here, you should probably move it up to the negative 4. Put it on the top or the bottom, one or the other. I'm going to leave it on the top. So now 1 times negative 4 is negative 4. Minus, because that's a minus sign, 9 times 1 is 9. And then over 9 times 1 is 9. So negative 13/9. That's what I'm getting. Is that okay? Nine what? Say again? Here? It's multiplying across. I'm using that shortcut formula. Remember that I showed y'all? I gave you a formula. I said, here it is. I tried to convince you where it came from, but I said at the end of the day, just try and remember it goes multiply here, minus, multiply here, and then the bottom will always be multiply straight across. All right, how do you feel about that? Evaluating functions? You'll have to practice, of course. I'm trying to figure out if there's a point at which I want to stop, because I don't want to put so much information on the test that it's going to be a problem. Yeah, we'll do one more topic on this. I think one more thing, and that will be enough. All right. Finding function values from a graph. This is a weird topic because students usually like get it and it's like no problem, this is easy, and then like if the light bulb hasn't gone off, like students get really confused. So I'm going to draw you a graph of a function. And it's going to be, I'm trying to show a little bit of detail. These are like grid lines that kind of help keep track of where things are. You don't have to be a perfect, exact copy of this, but okay, so here comes the function. All right. You can do your best to copy that. So this is x is the input, and the y-axis is the f of x. First question, find f of 0. So all of these are increments of 1. So that's 1, that's 2, that's 3, and then this is 1, then 2, then 3, so on and so forth. So what is that asking you to do? What does that mean? Find f of 0.
Find where it crosses the x-axis at 0. I mean, the y-axis at 0.
At what 0?
So on the y line. So like, if the line, so this is y, if the lines run across y this way?
This is y, this is x.
Yes.
Right, okay.
Yes. So you're going to find.
You said y, so I'm just, okay. Okay.
So yes, so you're going to find where it crosses here.
Okay. So you're saying this is your x value,
Yes.
right? So x is your left and right, and you're going to try and figure out where the function is crossing that. Am I interpreting that correctly?
I think so, yes.
Okay, so I think your interpretation is this. 0 is x, right? So x is left and right. So this is x is 0, this is x is 1, this is x is 2, 3.
Yes.
Okay, so we're going to x is 0, right, which is right there. And we're trying to figure out where our graph is touching this way. Yes, okay, yes, I agree with that. I agree with that. You're just going to go to the x value of 0 and look up and down and see where your red graph is. And wherever it is, you're going to pick off the height of that point. So it's right there, isn't it? And how high is that point? 3. 3 units. So it's almost like this is what you're saying. You're saying that the point 0, 3 lives on that graph. Plug in 0, you spit out 3, right? Plug in 0, you spit out 3. Questions on that? Okay, how about another one? What is f of 2? F of 2 is 0. You go to 2 on the x-axis, and you look up and down trying to figure out where your point is. And it actually turns out that it's right there, right? So what's the height of that point? 0, right? It's not up, it's not down, it's right on the x-axis, so you get 0. All right, C. Find f of 3. What's f of 3? Looks like negative 3, right? So you go to x value of 3, 1, 2, 3. You look up, you don't see anything. You look down, up, there it is, right? Now, what's the height of that point? It's negative 3. That's how far down it is. This one's a little bit different. This is actually asking you the reverse question. It's saying, hey, look, don't look at the x value of 0, x value of 2, x value of 3, and tell me what the y value is. Instead, it's saying, hey, the y value is 1. What's the x value? So where on your graph is the point on your graph 1 unit high? Negative 3. Do y'all see that right here? Negative 3. And negative 3 is in our graph 1 unit high. But is that the only answer? Or there's another place where the y value is 1. Looks like about right here, right? It's not a very good picture. I think you would have to guesstimate that. What would you say? Half? X is a half? Would you all agree on that? Okay. On a test, I would make sure that it's very clear as to where that point is. Yeah, sorry, not a half. 1.5 is what I meant to say. 1.5, not a half. A half is right here. 1.5 is here. That okay? All right. All right, so the last thing, we got 20 minutes. Let me just talk about what's for homework. Don't start packing up. It's not over yet. I'm also going to pass around this sign-in sheet. Okay, there you go. So for homework, it's page 39, 40, yeah, 39 and 40. And then 45 through 48. You got that? 39, 40, and then 45 through 48. And then page 51. Yeah, and that's it, page 51. Questions on that homework? Okay, the last thing we're going to do is I'm going to give you a group quiz. All right? So you're allowed to work together. Almost, you know how I usually give you problems and let you like work on them and I'll like step out of the room or something? I'm going to give you a couple of problems to do. You can work together and then turn this in. So this is just there to kind of help your grade a little bit. You know, if you work together, you should be able to get it. And I think what I'll do is I will give you something off the review. That way you're kind of killing two birds with one stone here. Everybody turns in their own page. As soon as you finish this problem, these problems, you may go. Can you all see those?
Yeah.
Why don't you do those two problems? These are right off the review. We talked about this a little while ago about how you go about doing those. As soon as you're done with it, turn it in. Let me just look over it to make sure it's right, and then you can go. And make sure you've signed in.